Hi there, my name is Sam Morris. I am a solutions engineer at Chainguard. Today I'm going to walk you through the life cycle of a CVE, how to remediate it and patch it manually, and how you can use a hardened minimal base image to not have to ever do that again in your life. Alright, so let's get started here. If I have my Docker file open for my application, it's a Python-based application, the only line I want us to pay attention to right now is this Python 3.12 Alpine. So this is a slightly older version of Python that my application is based on. This is my base image, right? So let's go ahead and just scan the base and see if there's any vulnerabilities that pop up. So I'm going to go ahead and copy and paste this just for the sake of time. What I am doing here is using Gripe as a scanner. You can use any scanner you like, but in this case I'm just using Gripe for the command line. And I'm grepping for critical vulnerabilities. This is just going to show me any vulnerabilities that exist in this base image. Goes in, pulls the image, parses its contents, checks the metadata, and checks against the National Vulnerability Database for any CVEs. In this case, we have one critical CVE, which is bad. My organization doesn't let me have critical CVEs in my code base, which is best practice for sure. So I see that Python 3.12.12 is my Python version. And this vulnerability is identified by CVE 2025-13836, which I can see right here. I can also see in this column, it doesn't spell it out here, but I have to upgrade my Python version if I want to get the fix for this specific CVE. Whoa, let's slow down. I'm not able to upgrade my Python version just yet. I have to be on Python 3.12. I need it for Alpine, which is already a pretty minimal image. But I do need this vulnerability gone. What do I do? Well, my next step is to search this vulnerability on Google, right? So I'll just make this a little bit smaller and we'll take a look at the vulnerability together. All right, boom. So I search it up and I see its record and the NVD. Fantastic. This will tell me more about my CVE and what I have to do to fix it. So in this case, it gives me a description, and it says the CVE is when reading an HTTP response from a server, if no read amount is specified, the default behavior will be to use content length. This allows a malicious server to cause the client to read large amounts of data into memory. This can cause a denial of service attack. Obviously bad. We don't want to have denial of service attacks. We don't want our application taken down, so we do want to remediate this critical CVE. I see why it's critical. If I scroll down, I can see how I can remediate this. And in this case, it gives me a few different options. Obviously, Gripe told me I could upgrade my base image, which I'm unable to do. Maybe I have some dependencies that aren't in a different version of Python, or whatever the case may be. You can't upgrade the base image. But I can apply a patch manually. And this is a case that many enterprises might have to do, especially for more legacy software. So I have to go continuously scan and also find the change. Thankfully, there is one upstream, and I can even see this specific commit where this is fixed. So if I click here, I can see in this commit 14b1 FDB is just the smaller version of the full commit SHA. I can see the changes that were made where I'm changing the min read buffer size, going through, adding additional changes to solve this specific CVE, right? So that I don't have my DOS attack. Great. I see mostly the logical changes are in this client.py file and the lib HTTP folder within the Python package. Great, so there is a change that exists. Now, how do I go about applying this in here? Or before I even try to patch it, I want to test if this is truly a malicious thing. So this is the other aspect of things, is you might want to see, like, is this really a problem in my version of Python or whatever my base image is? I have to come up with some testing mechanism, which I did come up with. So I know the context of the problem. I'm going to go ahead and run a quick container. A container is a running version of an image. It's kind of how you can think of that. It's a process. So I'm going to run this and specifically try to call the malicious code. In this case, I'm checking that specific command of import the HTTP client. So we are using the client.py. And I'm checking to see if that change, in this case, yeah, if it has the attribute min read buff size, which was introduced in the code change. Let's go ahead and run this and see what the output is. So obviously it's an if-else. If you're vulnerable, you print vulnerable, apply one of my patches. So in this case, it does not have the attribute min read buff size, so we know the code change does not exist in our version. It's just an additional check you can do. And we're going to repeat this when we do patch the image. All right, so let's go through and apply the patch. So to do this in an Alpine-based file, Alpine uses APK as its package manager. I can do an APK add curl. So I'm doing this to add curl kind of to my, now I have to have curl in my image, which is already not great because now I can just download stuff. Someone gets hold of this image. So I'm adding curl because I need to download that specific file from GitHub, right? So going through, adding the file, I add the commit SHA here. Remember, it's 14b1fd. I'm pulling this commit SHA directly from the GitHub link. And I'm also downloading the new version of client.py based on that specific commit SHA and replacing it in my Python 3.12 package. Then I do my standard, copy requirements, pip install. All this is the same. I'm really just adding these few lines here to do the patch, which I now need to do for every single vulnerability. Thankfully, this image had one specific critical, but this can explode into the hundreds, especially if you're including critical and high and more. It can get quite explosive very fast, and you can get very large Docker files and a lot of work of just seeing if this even impacts you. All right, so let's go ahead and build this image. So I'm going to build, this is in the backend file, so I'm going to copy and paste this command. All right, I'm doing a Docker build, giving it the tag CVE lifecycle backend, giving it the context of the backend folder so it knows which Docker file to look at. And it does the build. I already built this previously, so that's why the cache was used by Docker, so you'll see the build if you run this from scratch. All right, so the image was built. Awesome. Let's go ahead and run this. We're going to do Docker run, and we're doing the exact same command as before, but instead we're going to use CVE lifecycle backend as the image choice to run the container. And it says, look, patch. So this now obviously is just checking for this attribute in the code, which it should. It's just showing that we did successfully download the right file, build it into the image, run the command, and see that the CVE was patched. Awesome. So what if we do a gripe scan on it? Let's check to see if the vulnerability still exists. So I'm going to copy and paste, gripe CVE lifecycle backend, checking for critical vulnerabilities, doing the same thing, parsing the image, parsing the metadata, and look, we still have the CVE. Great, I thought we patched it. It literally said, I'm patched, I'm good, you added it, you changed the file with the code that was causing the CVE. What's the problem here? Well, the problem is the scanner might not know that it was patched. It's only looking at the package's metadata. It's not, so it's looking and seeing you're using Python 3.12. We know about the CVE that exists in this version of Python. You can't get past us, despite your hacky adding a patch to your Docker file. So what do you do now? Well, for gripe specifically, and this will depend on what scanner you're using, but you can create like an ignore file. So in this case, I'm going to create a YAML file. Let's build one together. I'm going to call it gripe. Oh, there we go. I did something in a different window. Or new gripe YAML. .gripe.yaml. So this is how gripe will know that we identified a false positive. And the contents of this file are going to be simple. I'm going to paste in my ignore and give it a little bit of context here. So in this case, I give it, and this is all up to y'all what you want to add to your comments, but I added the CVE, I said I manually patched the client.py file, I verified with this command, I applied the patch, and then also I gave the patch link. So this is some good context to have if anyone looks at this file. In this case, I'm just ignoring in code. I'm ignoring the vulnerability, and then I give a reason. So I have to now indicate this is a false positive. It's detecting something that is no longer a problem. There's different types of false positives. It could be that it's detecting it, but this does not apply. In this case, it just is not in our code anymore. We have downloaded a different version of the file. All right, if I rescan it, I'm just going to give it a slightly different command. This actually I don't think is fully required for Gripe to specify the config file, but I am going to with the --config flag, my Gripe YAML, and I'm going to grep the critical CVEs. Go through. It still says 1 critical. This is just the output of Gripe, but you see the vulnerability does not show up in the output anymore. So if I do, you can kind of have it show up in different ways, but the vulnerability no longer is being detected because the ignore file is applied. So what's the problem here, right? That didn't seem like a lot of work at all. And maybe, you know, it was a few minutes that was pre-rehearsed before this was recorded. And there's still effort in trying to understand what the CVE is. Does it apply to us? Is this file even called? Is this function even called within the file? All this stuff. There's a lot that goes into triaging a CVE. And you can imagine the amount of explosive effort that this can cause for all levels of severity. If you have more than 1 critical, if you have multiple base images, because these are not necessarily... you're not necessarily only building Python applications. So you can see how this scales really poorly and is a difficult and painful process to essentially rebuild from the commit. All right. So in comes Chainguard. Let's see how we can solve this with a minimal base image like the Chainguard Python base. So I'll show you really quickly our console. So I'm going to go into Python right here. So we see Python as a image option. We have, at this time of recording, over 2,000 images in our catalog. And we see a few different versions. So in this case, look at Python 3.12 right there. It's right here in our console. It was last changed 1 day ago. So this is constantly being updated. It also matches the minimal version of Python. So it matches the Python 3.12. Alpine is tracking 3.12.12. I call this out because there's some finicky things to understand about how open source software is released. But if you're ever curious about our product lifecycle, we're going to apply upstream patches to current releases. So if I go down to Python specifically, just to clarify this, we're kind of looking at release tracks and how stuff is released. But in this case, the maintained upstream releases will be 13, 12, 11, 10, and 9. So since we're using the 3.12 tag, this will ingest the latest changes. So even if a change is introduced after 3.12 was initially built, we are still going to apply a patch to it because this is a currently maintained version stream. Specifically, 3.12.12 is a floating tag. It's also pointing to 3.12, or 3.12 is a floating tag. It's pointing to 3.12.12. So if you're using 3.12.11, it would not necessarily get the same patches because that is now an out-of-date thing. Like this, 3.12 old, if it's an older version than 3.12.12, it wouldn't be getting the patch. I like to clarify how this works because I think it's really key in understanding that we are still applying fixes to older versions, but they have to be actively maintained, like the latest version of an older version, if that makes sense. So that is our product release concept, right? So how are we fixing these things? I can pull this Python 3.12 image and use that instead. So if I look at my Docker file Chainguard, you can see it's a lot smaller and let's see if I can make this screen a little bigger. It's a lot smaller, a lot cleaner. So in this case, I'm using Python 3.12. I have a dev variant because I do need to do pip install just for this specific Docker file. You could also do a multi-stage Docker file and get rid of the dev variant. But for the sake of this demo, that's why it's Python 3.12 dev. All right. So let's go ahead and, I'm also going to remove my gripe ignore because I don't want to cheat here. I don't want it to show up in my ignore. So this is no longer in there, right? Okay, cool. So let's go ahead and do a build. So I'm going to do Docker build T, and I'm going to call this CVE lifecycle backend Chainguard. I'll just do a dash Chainguard for my tag there. And then I have to point to the context, which is backend. I actually have to put in a few things here. So I have to put in my file is going to be dockerfile.cg, and then my context will be backend. There we go. All right, let's build it. Oh, and I have to make sure I'm pointing to the right place. Backend. There we go. All right, so we build the image. Cool. Let's rerun that same gripe scan, but we're going to run it on our Chainguard image. Paste. I'm not scanning the base image again. Just going to scan the application that we built for the sake of time. So if I do a gripe CVE scan for criticals without that ignore file, we can go ahead and parse the image and see what's going on in here. This case, we see 0 critical. So the vulnerability does not exist in the base image. Why? What happened there? Again, you said you would patch this version of Python, but what did you do? Well, let's actually look a little deeper into this because it's quite interesting. So if I go into Python 3.12, I'm going to open up this a little bit bigger. I can see my SBOM. My SBOM showing all of these APKs that exist in here. But what I'm interested in is Python 3.12. This is the package that was malicious in the kind of public version that I pulled from Docker Hub. So if I go in here, I can see the Wolfie repository, and I see Python 3.12. It's pointing to 3.12.12 that is currently maintained. I also see an epoch number, epoch or epoch, whichever way you want to say it. It's showing that there's some revision to this. And we detail a little bit more about what this means in our product release document as well. Let's just go ahead and look at the history here, because now I'm curious about this file. What did I do to get that change? So I go in here and I see a few different things. This is a pretty long file, but let's just go ahead and see the history here. So I can see the commits to our Python 3.12 package. There we go. If I click the history, there we go. I can see the commits directly to this package. And I see a cherry pick to fix CVE 2025-13836, which is looking pretty familiar. So what is this doing? We actually add to the cherry picks the exact commit that I added to my Docker file. 14b, 1fd, etc., pointing to that CVE. So this is actually cherry picking a specific commit in the Python repository to add that patch to this version of Python, Python 3.12.12, denoted by the floating tag Python 3.12. So since this is a currently actively maintained version of Python, and this change came in even after the first Python 3.12 was released, we don't just stop there. We're constantly rebuilding our images from source meaning the commit. Hopefully this helps in understanding the life cycle of the CVE, what someone might have to do to patch a CVE themselves, and also how our factory goes and watches for these changes and applies them to currently actively maintained versions. Again, you can take a look at that again in our product release notes, what that means for you, but is adding these changes so you don't have to. You don't have to go through, validate the change even worked. You don't have to check what it's doing, do some hack of curling, in this case it curled the whole file, or applying a specific change using maybe like a sed command or something like that, adding different packages to do all of this changing and updating. For every CVE, we go in and we take care of that for you by applying these changes to our Wolfie package repository, making these updates, rebuilding this image, and bringing it directly to your doorstep. Your doorstep meaning your Chainguard registry. Again, I'm Sam Morris, thank you, and I hope you learned a little more about the lifecycle of a CVE.